Hello everyone, welcome to this video. In this particular video, we're going to be taking a look at Docker Security Essentials. So what we're going to be covering in this video is going to be all the various security techniques and features that you can put in place to ensure that your Docker environment, your Docker host, and your Docker containers are running as securely as possible. Given the rise of adoption or the increased adoption of Docker and containerization in general, it's very important that you understand how to secure your containers, similarly to if you were running virtual machines. Now, this video is not going to be focused on how to use Docker. There's tons of videos and tutorials that can guide you on that. I'm just going to give you a brief introduction to Docker, and we're going to talk a little bit about the architecture, and the architecture will give us an idea as to what the potential security issues might be. So firstly, what is Docker? Well, Docker, you can classify as a containerization technology, right? So Docker allows you to build and deploy applications and services in the form of containers. It's a platform as a service offering that utilizes the host operating kernel as opposed to hypervisors, type 2 hypervisors like VirtualBox. So the containers contain the dependencies and the libraries that the application or service needs to run, therefore eliminating the need for installing dependencies manually. And Docker containers are much more efficient than virtual machines as they utilize the host kernel and remove that added layer of resource consumption. So all of this can be explained by taking a look at this diagram that sort of differentiates Docker or containerization and virtual machines or type 2 hypervisors. Right now, in this particular case, we have a type 1 hypervisor, but the concept remains the same. So with containerized applications or with containerization, what you'll have is you have your hardware, right? So you're going to have your hardware or your host hardware, and then you're going to have your host operating system, which can be Windows or Linux. It will certainly be Linux in most cases if you're running Docker, and then you install Docker on top of that, and then you have your various containers. Now, if you can actually compare this to the example of virtual machines, you can see that for each of these virtual machines, we also need to set up their operating system. So we need to set up the guest operating systems. And what this does is, as efficient as it is, these operating systems consume a lot of resources. Now, in the case of Docker, all the containers are utilizing the host operating system kernel. So for example, if I am running Ubuntu 18.04 and I'm running Linux kernel version 5.4, then all containers that might be running they might be running Ubuntu, CentOS, they could be running Apache, will all be utilizing the host operating system kernel. And we'll use that as part. We will actually use that functionality of the host operating system. And again, we can customize this, or we can customize the extent to which the host operating system is used. And that's where we start getting into the various security issues, because one of the security issues that you can immediately tell or point out is the fact that if we are able, or if there is a vulnerability within the host operating system kernel, then it will affect all containers. So now that we have an understanding of the infrastructure behind Docker and your typical type 2 hypervisor or virtual machines, we can now get started with securing Docker. All right, welcome back. So we can finally now get our hands dirty, but there are a few things or a few concepts that I want to explain that'll really give you a better idea of why we need to approach security in regards to Docker at various levels. Now, this particular video is going to be focusing on the essentials. It'll sort of be an introduction into securing Docker, and will sort of open up your eyes to exactly what can be done and what needs to be done. So when we talk about securing Docker, we need to understand it, given the actual architecture that I displayed or actually took you through within the presentation. So you're going to have your host operating system, and that's vitally important. So, the security of your host is going to determine the actual security of your containers. For example, if I was running an insecure version of Ubuntu with an insecure kernel version that was vulnerable to the dirty cow exploit, any one of the containers running on that host or that version of Ubuntu would be able to compile the exploit and get root access that way. So host operating system security is vitally important. So the first thing you need to do is you need to decide on an operating system that you're comfortable that you're comfortable with using. And of course, in this particular case, I'm referring to Linux, and we're going to be talking about various distributions that you can use as your host operating system. So when we talk about security, there's the concept of the threat surface, right? And the larger the threat surface, the more difficult it is for you as a user, as an administrator, as a DevOps engineer to cover every aspect of security. So the first thing you want to do is you want to have a minimal setup, right? So there are many minimal operating systems that you can use, and we recently had the Core OS, I believe it was called, that was actually set up to run containers. And again, the way these operating systems are being set up is to run whatever or only what they need, and getting rid of all the other bits of functionality that are set up to be used by normal users. So a typical distribution like Ubuntu, it's really good for running Docker. And you can also use CentOS or Fedora if you like, but essentially you'd like to use something that you're comfortable with and that you're comfortable securing. Now this video, we're really not going to be talking about securing the host operating system per se, but I'll take you through some important aspects of it. So firstly, you can see I'm currently on the CVE details website that lists out the various vulnerabilities for Docker over the last couple of years, right? So, from 2014 all the way to 2019. And you can see in terms of software, it has a very good track record in terms of the amount of vulnerabilities that is. In terms of severity, we have a few, really big ones here. So for example, we have the number of vulnerabilities released for each of these years comes to a total of about 24, which is, great. You then have the types of vulnerabilities. So we have DOS, code execution, which is probably the most important one. But if we take a look at the other categories, we have overflow, memory corruption, SQL injection, directory traversal. Each of these, or all of these, mostly all of these, don't have any vulnerabilities. So, in that aspect, Docker is doing really well. Now, when we talk about Docker vulnerabilities, these are vulnerabilities within the Docker daemon or the Docker engine itself. When we talk about how containers can leverage vulnerabilities within the host operating system to get root access or to gain access to other containers, that's a totally different story. So in terms of securing your host, you want to make sure you're running the latest version of Docker. Secondly, you want to make sure you have all your packages updated and upgraded, and you're running, you essentially have everything updated and nothing on your system is vulnerable. So that will pretty much mean that if you're part of a large organization, that particular host is part of a vulnerability management program. And we also have services now that actually add or allow you to add containers to your vulnerability management program, so that you can also track vulnerabilities within containers as well as the host. So you want to make sure that you have your host locked down, so you can perform the typical Linux security best practices, which I already have a video on, so you can check that out. And then of course, when we talk about minimal operating systems, or operating systems that have been designed to run on the cloud or to run containers and are extremely secure, one example of this is actually going to be Clear Linux. So Clear Linux is an open source rolling release Linux distribution optimized for performance and security from the cloud to the edge, designed for customization and manageability. So you can check this out if you're interested in this. As you can see, it's set up exactly for what we're doing right now. So operate with a custom configuration. It's close to upstream, so you get the latest packages. It's a modular, so again, it's open source, so that means it's modular, cross architecture, open source operating system, providing the ability to it provides users the ability to differentiate, so to actually create your own custom configuration if you wish. And it's Intel optimized. So again, that's something that you might be interested in as well. In terms of Ubuntu, if you really are looking for a minimal operating system, I would recommend taking a look at Ubuntu Core, which is set up for embedded devices. So if you're looking for a good host operating system that's minimal, I would recommend checking this out. There's also other options like Rancher OS, which you can check out for yourself, but we're not going to be focusing on that. We're simply going to be running Docker on our Ubuntu 20.04 server. So I'll be taking you through the various techniques that you can use. Okay, so the first security technique that we're going to be taking a look at is going to be the process or the practice of always running or launching containers with an unprivileged user. Now, the reason you would need to do this, or you know, it's actually recommended that you do this, is to prevent privilege escalation attacks, right? So in order to actually run or a particular container from a Docker image as an unprivileged user, you need to control the build process for that particular image. So that's another security best practice that you should incorporate, and that is to build your own images. All right, and this gives you the ability to set up the environment based on the parameters you're aware of. So for example, in my particular case, I can build a simple Docker image using one of our Docker images that we created. It's called the Bug Bounty Toolkit. So we'll just use the Docker file here. You can see it's based on Ubuntu 18.04. And we don't set any particular unprivileged user here. So we are going to be doing that. So, you know, I'll just, we can just copy this here. I'll just copy the first few commands because the rest of the commands essentially set up directories and install tools. So what we'll do is we will begin the setup process. So I'll just take you through the process of what you do when you're running a standard container or a standard image. So if I list out my Docker images, so if I say Docker images, you can see I have an Ubuntu 18.04 Docker image. Now you would typically run it by saying, you know, Docker run, and then I'd say we want to use a terminal, and I want it to be, I want to get rid of this container when I exit, and then we specify the image ID, right? So we can specify the image ID, and then I can use a shell. So I can say bin bash, hit enter. You can see that it logs us in as the root user. Now this may actually seem like a trivial thing, but it actually isn't recommended. Would you give root access to anyone, or would you give root access to a person on a server? The answer to that is no, even if it's running services. So you need to take the whole concept of host security into the containers. So that's the first thing we need to do. Now, when it comes down to creating these users, I'll just exit from this particular container. And if I say Docker, we can say Docker PSA. You can see we don't have any of these containers running, which is excellent. So as I said, we'll be building our own, we'll just create our own Docker file. So we'll say vim Docker file, and we'll just hit enter. And of course, this is going to be done locally, and we'll just copy this initial configuration here, and I'll just insert, and we'll put that in there. Fantastic. So in terms of the environment variables, I can set my own environment variables, right? So I can set up, for example, we can say home, and we can set up the name of the user that I want to create, the unprivileged user that I want to create, which is going to be Alexis. And remember, if you do require root privileges, you can actually just specify that under, you can actually just specify that within your Docker file. So, you know, you don't need to actually have, or you don't need to specify permissions for that user for your Docker file to be built, right? So that's in terms of installation. It's just when you're running the container, which is the important bit here. So to add the user, all we need to do is say run. So we're actually running a command here, and the command we want to do is, or that we want to run, is going to be called group add. So we're going to be saying group add, and then we specify the user, which in this case is going to be Alexis. And again, you can customize that to whatever you want. So we can say Alexis, and then we're going to say user add, and we're going to specify the group. So user add R and G, and then we specify the group. In this particular case, we're not granting Alexis any particular privileges or any pseudo privileges, but we could have done that. I can say, you know, for example, sudo, and then say Alexis. But in this case, I'll just add Alexis to his own group. So Alexis, and he is a fully unprivileged user. So that means he can't do anything that requires root privileges. So now that we've done this, you can see that immediately below this, we can begin the configuration if we actually want to do that. But in our case, we're not going to install any particular piece of software. But, you know, just for instance, or for the sake of this particular video, I can say, you know, run. We can then say, you know, apt install nicto, or just any commands over here, but we're not going to do that. So I'll save this Docker file, and to build this particular Docker file into an image, we're going to say docker build, and we then specify this current working directory, which is where the Docker file is being stored, and then we specify a tag, and we'll just call this, let's just call this particular image test, and we hit enter, and it's going to begin the build process. And you can see it's complete. And now if we list out our Docker images, you can see it's going to say, it's actually just going to say test. That's the Docker image that we created. So now when it comes down to running this particular image, you can see that we can approach it two ways. We can say Docker run, and I don't need to specify a user, and I essentially just launch it, and it'll actually use the root user. But however, when it comes down to, as I said, running Dockers securely, you want to make sure that you use an unprivileged user. So if you want to use a user that you've created in your Docker image, all you need to do is say R, and then we specify, all we need to do is say, we specify the user, so we can actually use you here, and then we specify the username or the user ID, which can be obtained using the etc password file. So the user is going to be Alexis, and then we specify the other run options. So for example, Docker run user Alexis. We can also just say we're running this and we want it to get deleted, and then we specify the image ID right over here, and we'll put that in, and then say, you know, bin bash for a terminal session. And there we are. So we're now logged in as the user Alexis. And remember, even if we have the root user added and we haven't disabled it, but we actually can do that, I'll show you how to do that shortly, we can't actually switch to the root user because we didn't set the root password. So if we give this particular image to someone, or, you know, if we give this particular container to someone, or we give them access to this container, they can't escalate their privileges to root, and they can't do anything that would potentially compromise the container or the services running within the container or the host itself if there are vulnerabilities within the host. So, you know, the user can't install new software. They can't muck around with the services running inside. They can't compile anything. So and they cannot execute anything that, again, may damage the system. So we can then just hit exit here, and we can close that out. So again, if I just list out my Docker images, I'm just gonna get rid of this particular Docker image that we created. So I'll just say Docker RMI, so Docker remove this image, and we'll just put in the image ID there, and that's going to get rid of that particular image. And then, of course, as I said, we can modify the Docker file to lock or block access to the root user completely. So for example, I can say immediately after this, I can say, run, and I can, say, for example, we can echo out a command, or we can modify or prevent access by using the change shell command, and then we can change the default shell for the root user and prevent, we can actually prevent a user from logging into the root user account even if they have the particular password. So again, we can essentially just specify the terminal for the root user as user sbin no login, similar to what you do when you are securing the root account or disabling the root account on Linux. So again, all we need to do is just provide the command. So we can say change shell, and we say the shell is going to be user sbin no login, right? And then we specify the user that we want to specify, that the user of whom, or the terminal for the user that we actually want to switch. And then we just need to hit save, and then we can build this particular image. So we're just going to run the docker build command here. There we go. And it looks like that is done. And if we list out the Docker images now, all we need to do is say, we're just going to run the docker command again with the user Alexis, and we're just going to substitute the Docker ID here so that we don't have to type that in all over again. So we'll just copy that in there and put that in there and hit enter. And now if we try and switch to the root user, and even if we add the correct password and we hit for example test, it'll actually prevent us from logging in. As I said, we haven't set a root user password, but I can actually demonstrate this to you. So for example, if we go back into the Docker file, we can actually say, just before this, or even after this, we can actually just say run. We can then say password, and then we can then provide a password for the root user. But again, that's not recommended. But this is a great way of blocking root access or providing a user who is trying to escalate their privileges with no terminal that they can log into. All right, so that is essentially how to set an unauthenticated user and how to block root access for your particular images and containers. So again, it's always recommended that even if you're using a third-party Docker image, it's recommended that you get the Docker file and then change or customize the configuration based on the parameters that you feel are necessary, or you can secure it as required. That's the great thing about Docker. So we're now going to move on to the next step. All right, so the next security protocol or the security feature or the security practice to bear in mind is, the ability to run Docker containers in privileged mode. And of course, you then have the ability to restrict that. So it's always recommended that you never run a Docker container in privileged mode. And you might be saying, well, what exactly do you mean here? So if I just list out my Docker containers, let me just check if I have one. I don't. And of course, we created the image previously. So we're just going to be using that particular image that I created. So what I can do is I can say Docker run, right? And I can then say, the typical commands I'm likely to use. We want an interactive session, and I want to get rid of this container when I exit. And then of course I can say privileged, right? I can actually use that particular option, and this will run this container in privileged mode. You never want to do that unless it's explicitly required. So when it comes down to a new type of vulnerability, or a vulnerability that many of you who are security centric and have actually performed some penetration testing, you'll know of a typical or a very, 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 very simple concept in regards to set user ID binaries, and the fact that you can escalate privileges or abuse the set user ID binaries to run commands as another user. So for example, if within our particular container, if we had a set user ID binary that allowed us to actually run a command or run a particular binary with root permissions, we can actually leverage that, right? So as an attacker, we can leverage that to run various other commands as root. So if you want to disable this, what you need to specify is the security options. So we can say security OPT, which stands for options. So again, we say is equal to no new privileges. So very, very simple. So no new privileges. So that's privileges, and we then specify the Docker image ID, right? So I'll just copy this because I don't have my Docker image ID at hand, and I think I actually shouldn't have cleared that. So if we list out my Docker images here, and we again just go back to I'll just paste in that particular command, and we then specify the Docker image ID here, and we just specify we're just going to use bash by default. That is going to give me access, and remember, I can then specify to use the unprivileged user that I created. So let me just do that as well as an added security feature. And of course, you can automate the execution of these particular containers, and so we'll say run, and then of course we specify the user. In this particular case is going to be Alexis. Sorry, we actually specified run, but rather just a user, and then we say Alexis and hit enter, and we're now launched in as the user Alexis. So now if I had a set user ID binary here, I would not be able to actually escalate my privileges. And as it is already, I can't run anything or do anything that requires root privileges because I did not assign root privileges to this particular user. So that is in essence how to disable or how to work around privileged and unprivileged containers, and how to configure them to run as either privileged or unprivileged. All right, so now let's take a look at a security practice or a feature within Docker that allows you to specify kernel level or kernel functionality, kernel capability. And in the previous section we talked about running containers in privileged mode. When we say privileged mode, what exactly does this mean? Well, when we specify the privileged flag, what this means is that this will essentially give that container all Linux kernel capabilities. Now, if you've never heard of what capabilities are in the context of a Linux kernel, let me just introduce you to that right now. So I've just opened up the capabilities man page, which explains it really, really well. So again, capabilities, you can see for the purpose of performing permission checks, traditional Unix implementations distinguish two categories of processes. Now, I just want to intercept there. When we talk about modern operating systems and their permission and privilege architecture, you're going to have two modes. You're going to have privileged mode and unprivileged mode. And again, as it says here, in regards to the processes, privileged processes whose effective user IDs is 0, also referred to as super user or root, and unprivileged processes whose effective user ID is non-zero, right? So privileged processes bypass all kernel permission checks, while unprivileged processes are subject to full permission checking based on the process's credentials. So what this means is, in the previous section, when we specified the security option that essentially prevented us from upgrading or actually upgrading our credentials, in the event we were trying to abuse a set user ID binary, what that means is if we set that up, or we set up an unprivileged user and we assign the privileged flag to that container at runtime, we essentially just usurping or getting rid of the fact that we have specified an unprivileged user, because that container will still be able to bypass all the kernel permission checks and will be able to essentially run all the various capabilities that are listed right over here. So in terms of the various capabilities implemented on Linux, you have them sorted out here, and they all have a prefix, they're all prefixed with CAP or capability. And so, for example, the capability audit control enables or disables kernel auditing. So you can see, you can specify the capabilities that you want. And that's the great thing with Docker. I can run a container in privileged mode, which gives that container all in kernel capabilities, or I can specify an unprivileged user and then specify what capabilities I want that container to be run with, which is fantastic. So we can do this really, really simply by, again, if I'll just say docker run. And before I do that, let me just list out my images here. So we say docker run, and then I say, I can then specify the capabilities that I want to use. So, I can say capabilities, and that's done by using the CAP option. So capabilities, I can then say add or drop. So for example, what is recommended is that you drop all. So you say drop all, and then you add the ones that you want. So you can say docker run cap drop all. So capabilities drop all, and then you can say capabilities add, and then we can copy the name of a capability here. And we can just search for one that would make sense in this particular case, because they're all very, very powerful, as you can see. So for example, let's see if I can find one that makes sense. So we can use netadmin, which allows us to perform various network related operations like interface configuration, administration of IP firewalls, etc., etc. So that seems like a piece of functionality that you might want to assign to your container. So we can say capabilities add, and then we say we provide the capability name, and then I can specify, the other runtime options that I want, and then we can specify the user as Alexis, and we then specify the image ID here, and we specify the shell finally, and I can say bin bash, hit enter, and we now have firstly, we have dropped all other kernel capabilities. Secondly, we have specified the kernel capability that we wanted to use. And of course, I really am not going to be demonstrating what we can do with this particular kernel capability, but you can use the kernel capabilities list here to specify the functionality that you need, even though you want to run the container in an unprivileged mode or with an unprivileged user. So that is the process of using or specifying capabilities based on your requirements or based on your container requirements. And as I said, there is never a reason to actually run a container in privileged mode, because that's probably one of the biggest mistakes you can make when it comes down to running containers. All right, so I'm just going to exit from that container, and we can move on to the next step. We're now going to take a look at how to, prevent a container from writing any particular changes to the file system, or how to set up a temporary file system. So, this is it's a piece of functionality that's very, very important when it comes down to restricting your containers or restricting a service account or, for example, the root account. So what do I mean when I say, restricting access to the file system? Well, what we can do is we can actually specify and say that we want this container to run in read-only mode, which means that any user on that particular container or any service cannot make any changes or cannot write any files to the file system. Now you might be saying, well, this doesn't make any sense because my container or my image requires me to install particular files, or my web server will be dynamic, files will be changing. What do you mean I can't make any changes? Well, again, this is very important in relation or in context with other file system commands like the temporary file system flag or the temporary file system option, which allows you to actually save something temporarily or to save a file temporarily, and you can specify the directories that you want. So for example, if I wanted to run the Docker image that we created in this video, and I can say, Docker run, and I can then start specifying, for example, read only, right? So I can say read only, and I'll just run it as is. So we'll say user is going to be Alexis, and I'll just show you what's going to happen here. We'll say we also want to get rid of the container when we're done. So the RM option or the RM flag really doesn't correspond to the file system permissions in regards to writing files or to making changes. This is in essence for managing containers, and the fact that when I'm done with this container or when it's in an exited state, I want that container to be deleted. So that's just a personal preference because I'm demonstrating something here. So then I can copy the image ID here, and we can then just use bash, right? So we can log in. So remember, I can actually go into my root. Well, I actually haven't set up the environment variable, but I did actually create the home directory. So we can say home. Do we have that directory created? If I just say cd home, and we have we actually don't have a directory there, right? So if I say touch test, for example, you can see it's going to tell me cannot touch test or cannot create the file test. This is a read-only file system. So that means I cannot make changes regardless of what user I am. So you might be saying, well, that's weird. What if you're the root user? So let's try that out. So I'm just going to exit from the container, and instead of specifying the user this time, I can just specify, or I can just leave that out and log in as the root user. And I'm logged in as root, and I can say touch test, and I hit enter. And there we go. So it says, hey, you can make any changes to this file system. So this is a great way of, as I said, locking down access around particular users or particular services. Or you may just have a service that you want to lock down in regards to what files or what directories you can that particular service or that particular container will be able to make changes in. So for example, if I wanted to use a temporary file system, I can say we can say we'll still use the root user. I can also combine the read-only flag with the temporary file system. So I can say tmpfs, so tmpfs, and of course, sorry, we need to actually just say tmpfs, and then we specify the directory under which we can make the temporary file, we can make the temporary changes, right? So we can specify the opt directory, for example, and hit enter. And now if I print my working directory, I'm currently in the root. If I say something like, and as the root user, we actually have the permission to do this. If I say something like, touch test, and I hit enter, it's going to say, hey, you can't make these changes because this is a read-only file system. However, if I go into the opt directory, which is the temporary file system that we're specified, and I say, touch test, and there we go. So we can actually make changes within this directory. So this is a great way of locking or setting up restricted access, even though you may already have privileged users, or you may not want to use a privileged user. So there's tons of ways you can set up security with your Docker containers at large. So that is how to use or how to set up the file system type to use, and how to set up your temporary file system. All right, so we're now going to take a look at a very, very interesting aspect of container security. Now, if you remember, in the introduction, I briefly outlined the differences in terms of architecture, from containers and virtual machines, right? And one of the questions you might have if you've used virtual machines before is with a virtual machine setup, I know that I can isolate each virtual machine from one another, or I can essentially separate and isolate virtual machines based on their functionality, based on their purpose. And the way I can do this is by using various networking modes. Well, your question might be, can we actually do this with Docker? Can we do this with Docker containers? Can I isolate a Docker container? And the answer to that is yes. Now, previously with Docker, you had the ability to, outrightly disable or set inter-container communication to false. There was an actual flag for this, and many of you have used Docker for a long time actually knew about this, but now it's all being handled through a network. So what we can do now is, or what we're going to be taking a look at now, is how to create our own bridge network, and we can then specify the options that we want to modify. One of these options is going to be the inter-container communication. All right, so firstly, what we want to do is, let's take a look at the networks that we already have. Firstly, let me just check if I have any containers running. No, we don't. Okay, so to inspect networks, or the networks that come by default, is we can just say docker network and ls. So that's going to list out all the networks, and you can see they're sorted based on the type of network. So you have your bridged mode, which again allows all containers that are running on that particular bridged mode to communicate with each other. Now, by default, all containers will use the bridged mode, and I can actually demonstrate this to you, or demonstrate this for you. So for example, if I want to inspect this particular network, I can say docker network inspect, and I just say bridge, right? And I hit enter, and it's going to give us the subnet right over here, which again is 172.17. So let me just keep this here. Let me just note this down so I can actually prove that to you. So that's the subnet. So that means we'll have an IP within this particular range. Now, if we take a look at the other options, for example, enable IPv6, that's disabled, that's fine. And of course, you have the options here that I'm referring to. So we have the if I can find it, there we are. So we have com docker network bridge enable ICC. ICC is an abbreviation for inter-container communication. So by default, it's set to true. So we want to change that value to false. Now, the way we can do this is by creating our own network, and I'll show you how to do this in a second. So what I'll do is I'll just create a quick little container just to show you that it is using the bridged mode. So we'll say docker container. So we'll just say, sorry, docker run, because we don't have one currently running, and we'll just specify, the test image, and just say bin, and we'll just say bash here. Okay, so we're currently logged in as a root user. If I just say, apt update, and we actually don't need ifconfig ad, we just ipas. Let's just use ipas. We don't have ipaddr. So we can just say apt update and apt install let's see y, and we'll install net tools. So we'll just install that here, and we should be able to get the IP then. So we'll just give that a few seconds here. There we are. So ifconfig, like so. You can see it's set to that particular subnet that we had just copied over. So 172.17. So that means that if I create another container, we will essentially be able to communicate with that particular container. So for example, if I just I don't think I can actually demonstrate that, but let's actually move on to the process of creating our own network, so I can actually demonstrate this. So what I'll do is we will just use tmux. I think I have tmux here, and we'll just say container one, and we'll create a new session here, and I'll just rename this to container 2, right? So container 2. All right, so within container within container 1, which I'm actually active on right now, we'll just create a container similar to what we just did. So we'll say docker run it, and we'll say we'll just leave it as is, and we'll just run the test one. So test, and then we will say bin bash, right? And we'll just hit enter. So we have one container running. We'll then open up the second container. So I'll just move to my second section, session, and say docker run, same thing, the exact same options here, and we'll just say bin bash. and they're obviously going to have different IPs. So what we can do is, again, just say sudo apt, we'll just say apt update because we don't have sudo. So apt update and apt install we say net tools, and I'll just copy this particular command and run it in the first container as well. So we'll just hit enter, go back into the first container, run that particular command as well. And remember, all of these containers are running simultaneously. So we'll just let this complete. And now what we'll do is just wait for that to complete here. And there we are. So if I say ifconfig, we have the IP here, and let's check the container. We can actually run an nmap scan, but we're not going to be doing that. So ifconfig, and if I say, you know, if we want to ping this particular address, we can again just copy that. And if we go back to the first container and say, you know, ping that particular container address, so it's apt install ping, because we don't have that. I can't believe that's not there already. Apt install nettools. We've already installed nettools here. Do we need to do that again? Do we need to install nettools again? We already have nettools. So we should be able to ping. Ping is not found. So apt search ping. How come we can't find the ping package here? iputils ping. All right. So apt install iputils, and we say ping, iputils ping, like so. And we can then say ping that particular IP here, and you can see we can communicate with that particular container. So that's in essence how the bridge connection works. Now, if we want to disable you know, inter-container communication, all we need to do is, let me just go back to my second container here. So I'll just exit, and we'll close this particular container and this particular session, and I'll just leave this within tmux, and we'll just say, we'll just call it term 1. Okay, so we'll exit from this particular container as well, and our job now is to create a new bridge network that prevents inter-container communication. So the way we do this is by saying docker network, and then we say create, of course, and then we provide the driver that we want to use, which is going to be bridge. So we'll say the driver is going to be of type bridge, right? And we then specify the options that we want to use. In this particular case, we need to copy the additional option. I think I'd copied it, the option that essentially specifies whether or not we want to enable the inter-container communication. So I'll just copy that here, and we should be able to paste it directly. So there we are. So we'll just add the quotation marks. So that was the option here, and we've set it to false, okay, which is very important. And then we provide the network name. So I'll just call it test net. All right, so we'll just call the network test net, and we'll hit enter. It's going to create that network. So now we say docker network ls, and we list out that particular test net. You can see we can then say docker network inspect, and then we say testnet, right, to just list out the information. We've not specified the subnet information or any of the IP information. That's up to you. But the option that we're looking for here is, you know, the Docker network bridge enable ICC, and we want to set that to false. Okay, so now if we want to run a particular Docker image or a container with a particular network configuration, all we need to do is just say docker run, and we just again specify the flags that you like or that you're comfortable with in regards to the configuration, and then we say network, and that's going to be testnet. We'll run it with the test network, and then we just specify the name of the image, which in this case is just going to be called test, and we'll just run this with bash here. And if I now say, you know, apt install or apt update, let's just run that particular command. So apt update and apt install, we'll just say if, or I think it's net tools, and iputils ping, I believe it was, and we hit enter and let those packages install. All right, so we're just gonna accept that, and we should be good there. So if I now say ifconfig, we have a different subnet, but the main process or the main thing here is whether or not we have the ability to communicate with another container. And we wanted to disable that if we want to isolate this particular container. So I'll create a new terminal session here, and we'll just say docker run, and we'll run it on the same network, or even we don't even need to run it on the custom network that we created. All we're trying to see is whether one container can communicate with another, and the one that we've isolated, we want to make sure it cannot communicate with the other ones. So we'll say docker run it, and we'll just say bin bash. And the first thing you'll notice, of course, we actually have to just perform this cumbersome installation every time. So I'll just say apt update apt install y net tools, because we don't need the ping utility right now. So net tools ifconfig. So we've got you can see it's on a totally different network, but if we can also do it on the same. But if I go back in here and we say ping, for example, paste in that here, you can see it's not going to be able to get a response. Now that's on a different network. If we put the second container on the same testnet network, then again it'll actually be the same thing. So we'll just exit from here, and we'll then say docker. We'll just say docker run, and we then say it rm, and then we say we can then specify the network option, which again is network, and then we say test network. So test net, and then we say test, and that's the image name, and then bin bash. Hit enter, apt update. Let me just speed up this process. Apt update apt install y, and then we say net tools. I actually should have installed these packages within the image itself, or within the Docker file. I should have specified these packages to be installed so that we save time, but hey ho. All right, so there we go. We'll just say ifconfig. And now they're on the same subnet, so we can just copy that, and we can go back to the first terminal here and say ping, and provide that there, and hit enter, and you can see they can't communicate with each other. I can't communicate the other container on the same network, and they're all isolated. So if you want to isolate your containers, you can create your own network configuration. You can specify your IP configuration. I'll have all of this documentation listed out within the documentation for this video, so you can actually do that for yourself. So that is how to enable or to disable inter-container communication under the guise of isolation, which can be very, very important. All right, so now that we've taken a look at the various security practices that are recommended when it comes down to Docker security, and the key thing to understand here or to note is that this video has been focused on best practices in regards to running your containers and your environment. We really haven't touched upon the actual Docker platform and its own security. Now we can start performing audits, which is very, very important. When you set up security features or security protocols, it's very important that you set up an audit, or you perform an initial baseline audit, and then you make your changes, and then you perform the audit after that to see whether the changes you've put in are actually making a difference. Now in this particular video, I'll just be taking you through the various auditing tools that you can use, and then in the next set of videos regarding Docker security, we'll get into securing the Docker platform on its own. So the tool that we're going to be using right now is called Docker security, or Docker, I think it's Docker security bench, if I'm not wrong. So Docker security bench, if I can just search for that here, right over here. And there we are. It's Docker bench security, my bad. So Docker bench security is a script that checks for dozens of common best practices around deploying Docker containers in production. And now it's important to know that we haven't done things like enabling, enabling auditing, but again, running it should be fairly simple. So for example, all we need to do firstly is to, we can actually just get that we can just clone the repository here, and I'll just take you through a bit of the usability directly from here. So to use it, as you can see, running Docker bench for security, we can specify, the particular network, and then you can specify the various options that you want to run, in regards to the audit process, right? So let's move on to the first step, which is getting it set up. All right, so we'll just clone the repository here. So, we'll just copy the address here, and we'll just clone it to our root directory. So we'll just say git clone, and we'll paste in the address there. And we can then just run the script. So we'll just say docker bench security, and we'll run the docker bench security shell script and hit enter. It's now going to go through all the various aspects of the Docker platform. So you can see right over here, if we can just scroll upwards, let me just get out of tmux for a second, and I'll run that particular script again. So again, we'll just go into the Docker security, Docker bench security, and then run that script again. So if I can just list out that there, so there we are, and hit enter. And we can now scroll all the way through and take a look at some of the other options that again all have to do primarily, I'm going to guess, with the actual platform. So let's get started at the top. You can see it's going to go through various tests. Number one, you're going to have your host configuration. Number two, it's going to go through the Linux host specific configuration. So we'll then go through the Docker daemon, right, which is there. And then you have the Docker daemon configuration files, the container image and build files, and you have the container runtime, Docker security operations, the Docker swarm configuration, and enterprise configuration. So let's start off at the top. Okay, so number one, general configuration, nothing interesting there. For the Linux host specific configuration, you can see we have a warning for this option. So it says ensure a separate partition for containers has already been created. We haven't done that yet. So there we are. Second warning we get is for the auditing process, which I said we'll cover in the next video, to how to enable auditing. There's tons of ways we can do that, and all the other options also have to do with auditing of the Docker files, or essentially setting up an audit log or a system of auditing all the actions. All right. You can see that we need to ensure that network traffic is restricted between containers on the default bridge. So again, we can make changes to the default bridge, as I already did. I've actually shown you how to create your own network that sets up inter-container communication or disables that, which we've already done, so we don't need to worry about that. Enable the user namespace support. Again, these are things that we'll be covering in the next set of videos. Ensure that authorization for Docker client commands is enabled. We're running as an unauthenticated, a privileged user. Let's see, ensure centralized and remote logging. We haven't done that, so no syslog setup. Ensure live restore. Yeah, nothing there as well. As for the Docker daemon configuration file, we get no warning there, although the other files weren't found in regards to the daemon, so it doesn't run those particular tests. Right, we then have the contain images and build files. You can see that ensure that trust for Docker is enabled. Content trust, that is, and then ensure that health check instructions have been added to the container images, so we can actually do that. So add a health check for that, and then you have the let's see if we have anything else. So nothing else. So again, this particular audit is great for moving onwards now, because I've essentially taken you through how to run Docker containers as securely as possible, and we've talked about isolation. So this is how to audit the entire Docker platform as a whole, and I just wanted to take you through that, as we'll be using this tool as we move on through the Docker Security Essentials video series. Okay, so that concludes this particular video covering the essentials of Docker security. As I said, this is not a totally comprehensive video that aims to highlight every security practice or technique that you can run to secure Docker. As I said, securing Docker is a multi-tier approach, requires a multi-tier approach, as you need to secure your host, you then need to secure the Docker platform, and then you have the process of securing Docker containers and images. So as we move on in this series, we'll be taking a look at each of these aspects of security.